All right, I'm back. We are still on page 204. We're still converting from polar to rectangular, rectangular to polar. By now, hopefully you have some of these formulas memorized. X is our cosine, Y is our sine, R squared equals X squared plus Y squared. They just keep coming up, so you've got to know them. All right, so how are we going to do this problem? So this problem, I see R equals -14 cosine. I've seen things that look like this, and that's key. So I know that this thing should look like a circle. And I think the diameter of the circle should be 14. But because of the negative, it should be on the negative x-axis. So I think this will be -14, -7. We're going to go like this. And there we go. All right, so if I need the equation of this, the center is -7, 0. The radius is 7. So I'm ready to write my equation as the quantity x plus 7 squared plus y squared equals 49. So I am content with that. And if I were telling you that you had to do this, I would be content with you doing that. But let's take a look at how we can do it if we don't know that, right? So, and this is why this example in particular is why polar's a little tricky, right? So there's not necessarily one path to the answer, but we have -14 cosine theta. All right, I know two things that are useful. I know that r squared is x squared plus y squared. I also know that r cosine theta is equal to x. So I would like to make both of those things happen if I can. So I could square both sides to get r squared. And that's not a terrible idea. But then I have a cosine squared, and like I kind of don't really know what I'm going to do with a cosine squared. On the other hand, to get r squared and r cosine theta, I could multiply both sides by r, and that's what I'm going to do. So I'm going to multiply both sides by r. So I'll actually let's see, I'm going to do this. So like here and here, we're going to multiply by r. Just to like highlight what's happening here, because it's not really obvious. So this, also, I don't know if that's correct notation. I do it on the calculator all the time, and so now I like do it. I think it's probably frowned upon in the algebra 1 level. But I don't know. So here, r squared, -14, r cosine theta. Okay, this is good. This is good because r squared, I know is x squared plus y squared. And I know that, so it'll be -14. And then r whatever you are, r cosine theta, I know is x. All right, so we're like almost done, but we're not done because it's still not really obvious what this is. So what do you think we do? Did you say complete the square? If so, you are correct. All right, I'm gonna bring this over. I'm gonna leave a little space, say equals 0. All right, so what I do is I take U color. I take that number, divide it by 2 to get 7, square it to get 49, and add it to both sides. Plus 49 plus 49. Okay, so far pretty okay. And then the first three things will be a perfect square if you did it right, and that's x plus 7 squared plus y squared equals 49, which is the same answer that we got, but it's way more nuanced to get there, right? To get there, I had to think about, should I square both sides or should I multiply by r? Choose multiply by r. After that, I do my replacements, but I still don't have the form that I want. It's not obvious that that's going to be tangent to the origin. So then I like move it around, complete the square. You get to the same place anyway. Doesn't really matter, but I highly recommend that you think about and understand the pattern of these. Right, like every time you don't think about graphing lines anymore. You just graph them, right? You don't think about graphing trig. You just like graph it. Same thing for polar. You're just not used to it yet. So here, let's see. We got this. Okay, I see. R equals some number times sine. So I'm immediately thinking this is a circle that's centered on the y-axis, the positive y-axis, because it's 20 sine and not -20 sine. I know that the diameter should be 20. So this will be 20, which makes this 10. We get a circle. Circles are hard to draw. Okay, so I'm ready to write the answer, right? Because I know the center is 0, 10, and the radius is 10. So I am ready to write the answer as x squared plus the quantity y minus 10 squared equals 100. This is a pattern that is well worth knowing. Let's say you don't know it, so now you have to do the work. All right, so we have r equals 20 sine of theta. You have that dilemma. Should I square both sides? Should I multiply through by r? Choose multiplying. So I'll show it again using what I consider to potentially be sort of sketchy note. I feel like the better notation is this. I mean, I know that that's better notation. I still like using the other one more because it's like, I do it when I'm solving systems too. I'll just like put a boom and be like, I'm multiplying everything I see by 2. You know, I don't know. I'm cool with it, but there's a chance that I'm not the person who grades your work, in which case, do whatever they tell you to do. They will love you for it. All right, here we go. Substitutions, use a good color. This guy is going to be x squared plus y squared equals 20. This stuff right here is going to be just y, because our sign is equal to y. We're going to complete the square again. So, well, we're going to move it over and complete the square. So x squared is actually done. Y squared minus 20y, leave a space, equals 0. We take this number, divide it by 2 to get negative 10, square it to get 100, add that to both sides. So here we get x squared plus, now this will be a perfect square, that was like the entire point, y minus 10 squared is equal to 100. So we still get, we're getting the same answer, we get a circle that is centered on the positive y-axis, that is tangent to the origin, that has a diameter of 20. And we kind of knew that from the very beginning because we recognize the pattern. That pattern is worth it. Spend a little time with it. Do some examples, right? Like come up with your own circles centered on each of the axes and tangent to the origin, and like write their equations in polar and rectangular, convert them. You'll see it's a clear-cut pattern. All right, I'm gonna stop this video here, come back in the next one, keep going, because we're learning a lot of stuff about polar, so I will see you then.